the first lesson video show you some principles when using unit cost estimate. And the two major information that we need to get is the quantity from drawings and specification and the unit cost for each item. In this problem, we apply the concept of reading from the sketch, from drawings, and determine the quantity for the work. So that problem one, a contractor needs to install a 16 foot by 26 foot by 8 foot height footing to support 2 foot by 12 foot column for a building. So the two sketch here basically show the cross section in both sides of the footing, including excavation, slope of the excavation, and the column, etc. The size of the excavation need to be sloped at 1 so it means one horizontal and then one vertical as it's shown the slope in here. 2 foot space between the footing and the size of the excavation must be provided to form the footing as it's shown in here. You see 16 feet for the width of the footing, and each side you have 2 feet so that the work equipment can go to work on this footing. And similarly for the length of the footing, 26 feet, you also add 2 feet for each side. So that's what the problem mentioned. Perform the quantity takeoff for the following items based on the drawings provided. First, footing concrete, excavation, and backfilling. So let's apply that here. Before we get into the problem, I just want to go an overview of the method to determine the volume of a prismoidal shape. So if we have a shape like this, in 3D, we have that shape. And if we define the top or the bottom area in A1 and the bottom area called A2, and the height or the depth of the shape is L, the height of the shape is L, then the equation we call that is the modified average and area method. Modified average and area method. How to determine the volume of this prismoidal shape, and in this case it will be a V volume. It equal to L over 3 times the A1, the area of the top, plus the area of the bottom, or vice versa. And then we modify. Then we have square root of A1 times A2. And that is the volume. To determine the volume of the shape that you have, you know the depth or the height and the area of both ends of that shape, then we can be able to determine the volume with the modified average and area method. So with that, we have that in the reference. If you go to the exam 1 reference and item 3, we have the modified average and method and the equation there, definition. So you have that reference in there. So now apply to here, and that will apply for the excavation item B in this problem. But first thing first, we need to determine the A, which is the footing concrete. And with that footing concrete, as you can see here, they give us the basically a box, and that have the width, the length, and the height. So you just go ahead to find out the volume of footing concrete. I call it FC, and it equal to 16 foot by 26 foot. So it will be 16 feet by 26 feet. So we have 16 times 26, and the height is 8 foot high. So we have times 8 feet, and this feet times feet by feet to cubic feet. So we convert that unit into cubic yard that typical you have. So it's 1 cubic yard per 27 cubic feet. So from that one, we will get the footing concrete is 1, 2, 3 cubic yard. And that's the first answer. Very simple volume. So for those of you, when you see this here 2D, but we can imagine that the footing is basically a box with 26 one side, 16 feet the other side, and the height is 10 feet, 8 feet. So that the height in here. Give it 38 8 feet there. Now move to B. That is the excavation. To excavation. To put the footing concrete down, we need to excavate. Put the ground on, and it gives us the height for the depth is 10 feet, as you can see there. And we know the base for each side. The bottom one, 26 plus 2 at both sides for spacing. And the other side, 16 plus 2 at both sides. So we can be able to find out A2 and A1 for this excavation areas. So if you have that, it's similar to the excavation, similar to that shape here, and we can be able to determine the A1 and A2. So let the excavation, this is the original ground, so you have that in the excavation areas in that. And the excavation, we have that one here equal to V, and that using the modified average N area method, L over 3 A1 plus A2 plus A1 over A2. And in this case, what is A1 and what is A2? That is the one we need to do. So first, we have L. What we have? L is 10 feet for the excavation there. So you have 10 feet. What is A1? Give for a minute. We can have A2 first. Because I define in this, A2 is the bottom. You can put it, A1 is the bottom as well. So bottom is the rectangles, 26 plus 2 at both sides. So that is 30. And then 16 plus 2 at both sides. So it will be 20. So as you can see there, it's 20 feet times 30 feet. So you have that is 600 square feet. For A1, the top one, what do we have? What do we have? We have from here, let's get this side, from here to here is 30. And that one at 1, so you have 10. 1, so horizontal 1, vertical 1. So the 10 vertical, then horizontal have to be 10. And similarly, the other side, the top one, you will have here 16 plus 2, so this is 20 feet. And then we have both sides also 10 and 10. So from that, the top A1, it will be total 10 plus 10 20 plus 10, so we have that is 40. 40 time 10 plus 30 plus 10, 50. Then we will have that is 2,000 square feet. So from that we can plug in to find out the V for excavation, and I put EX for excavation, and the volume is equal to L over 3. L is 10 feet over 3. A1 2,000 plus A2 600 square feet plus square root of the products of 2,000 time, not plus, 600. And of course we change that into 1 over 27 to convert to cubic yard. So from here we get that is 1, 2, 3 in the first answer, so it will be 4, 5, 6. Just accidental, it had 4, 5, 6. And what is the unit in here? It's cubic yard, but then you can see that is from the original condition. Refer to the second lesson. Lesson 2 have to be BCY, bang cubic yard. Keep that in mind. At the original condition of the soil, so that is the bang cubic yard. And then the third one, we what is the backfilling? After you excavate, put the footing on, and then we have to backfill the material so that we can work on top of that, the foundation. So that will be the C. We have either backfilling. So for backfilling, what should be the backfilling? It will be these areas that I'm going to highlight in the yellow here. That is the backfilling area. So that backfilling, as you can see, it have to be equal to the volume of the excavation, subtract the volume of the footing, and subtract the volume of the column. So the column, as you can see there, the column, you see the part of the column, and then we also have to subtract the footing there, as you can see. And of course, similar for the top one, the backfilling is that what we need for the backfilling, and we have to subtract the column, and we have to subtract for the footing. Make sense? So we already know the excavation, we already know the volume of footing. What we need to know is only the dark blue, which is the column that occupy in that backfilling. So with that we can see the volume of concrete column that occupy under the ground. So that is V, and I thought CC, and it equal to, as you can see, the column they give us is support 2 foot by 12 foot column. So that is the area 2 times 12, and then the height of this one, and you can see height 8 here. So that one, the total is 10. So the height here, it will be 2 feet. Total is 10. Then this is 8 for the footing, and that one is 2 feet. So that's why we have to time the volume. It's 3 dimensions, so we have to time 2 feet for the height. And of course we do the unit conversion for that one. 1 over 27, and that what we get is not 1, 2, 3 cubic yard, 4, 5, 6. It's not 7, 8, 9, but in this case it equal to only 2 cubic yard for the concrete column. From that we can finally find out the V of the backfill. equal to, of course, as I say, excavation, the total volume of excavation, minus the volume occupied by the footing concrete, minus the volume occupied by the concrete column. And from that we have 4, 5, 6 minus 1, 2, 3 minus 2, and the answer become 3, 3, 1. What is the unit? Of course, cubic yard. But in the loose material, we have 3 types of measure: bank cubic yard, loose cubic yard, and compacted cubic yard. This is backfill. You put it back, and you have to compact it. So this one, it have to be CCY. That answer question. So as you can see, very important. We need to use correctly the unit and the process with the geometry, be able to read in the drawing. In the next lesson, we also give into detail how to read the drawings.